Imagine a world where the roar of a jet engine, the drone of traffic, or the chatter of an open office simply vanishes. It sounds like magic, but the reality of active noise cancellation is a complex, almost balletic dance with physics that creates an illusion of silence, not true quiet. This intricate technological feat, happening in milliseconds, involves an invisible battle against sound waves you won't believe. In this video, we'll unravel how these devices work, explore their surprising limitations, and reveal the clever engineering behind the quiet they deliver. You'll understand why some sounds disappear completely, while others remain stubbornly present. You'll also learn the key differences between various noise-canceling technologies and what to consider for your next pair. First, let's distinguish between passive and active noise cancellation. Passive noise cancellation is straightforward. It's physical sound blocking. Think of earplugs or thick earmuffs. The materials and design of the headphone cups create a physical barrier that attenuates sound waves before they reach your ears. This is why over-ear headphones, with their large, plush ear cups, often provide better passive isolation than small in-ear buds. They physically seal your ears off, preventing sound from entering. Passive cancellation is most effective at blocking high-frequency sounds like human speech or the clatter of a keyboard, but struggles with deep, rumbling low frequencies. Active noise cancellation, or ANC, is where the real wizardry begins. Instead of just blocking sound, ANC actively eliminates it. It does this by generating its own sound, an anti-sound, that precisely counteracts the unwanted noise around you. This is based on a fundamental principle of physics called destructive interference. When two sound waves meet, they can either reinforce each other, making the sound louder, or cancel each other out, making it quieter. ANC relies on the latter. Think of it like this. If you have a ripple in a pond, and you create an identical ripple but exactly out of phase, meaning where one wave goes up, the other goes down, the two ripples will cancel each other out, leaving a flat surface. Sound waves work similarly. If you can generate a sound wave that is an exact mirror image of the unwanted noise with identical amplitude but inverted phase, the two waves will collide and effectively disappear. To achieve this, ANC headphones have three core components: microphones, a digital signal processor, and speakers. The process begins with the microphones. These tiny sensors are strategically placed on or inside the headphone ear cups to pick up ambient noise from your surroundings. Some headphones use external microphones, others internal, and many use both, leading to different flavors of ANC. Once the microphones capture the incoming sound waves, they convert them into an electrical signal. This signal is then fed into the digital signal processor, the brain of the ANC system. This processor performs an incredibly complex and time-sensitive calculation. It analyzes the incoming noise, identifies its frequency and amplitude, and then, in a fraction of a millisecond, generates a new audio signal that is precisely 180 degrees out of phase with the original noise. This is the anti-sound. Finally, this anti-sound signal is sent to the headphone speakers. The speakers then emit this precisely engineered anti-sound into your ear canal, directly targeted at the unwanted ambient noise. When the original noise wave and the generated anti-sound wave meet, they destructively interfere, effectively canceling each other out and creating that coveted sensation of quiet. It's a real-time dynamic process that happens constantly as your environment changes. But here's the crucial detail. ANC isn't a silver bullet for all noise. It's particularly effective at canceling out consistent, low-frequency sounds. This is why the low hum of an airplane engine, the consistent drone of a train, or the steady thrum of an air conditioner seems to vanish so completely when you put on ANC headphones. These sounds have predictable, long wavelengths, making them easier for the system to detect, process, and generate an effective anti-sound. However, ANC struggles with sudden, unpredictable, or high-frequency noises. A sudden shout, a barking dog, or the crisp sound of a phone ringing often passes through the cancellation barrier relatively untouched. Why? Because the system needs a moment to detect, analyze, and generate the anti-sound. By the time it has processed a sudden sharp noise, the peak of that sound wave has already passed. The latency, however tiny, is enough for these transient sounds to sneak through. This is also why human speech, rich in higher frequencies and unpredictable patterns, isn't completely silenced by ANC. While voices might be muffled, they rarely disappear entirely. There are three main types of active noise cancellation, each with its own strengths and weaknesses: feed-forward, feedback, and hybrid. Feed-forward ANC uses a microphone placed outside the ear cup. It captures ambient noise before it reaches your ear and processes it. This method is great for canceling a wide range of frequencies, but it can sometimes struggle with very high frequencies and might not adjust perfectly to how the headphone fits on your head. Its biggest challenge is anticipating what your ear will hear. Feedback ANC, on the other hand, places the microphone inside the ear cup, near your ear. This allows it to monitor exactly what sound is reaching your ear and adjust the anti-noise accordingly. This is excellent for ensuring the anti-noise accurately cancels what you actually hear, and it's particularly good at reducing low-frequency hums. However, because the microphone is also picking up the music you're listening to, it requires more complex processing to avoid canceling out your audio. It can also be more susceptible to producing a slight hiss if not implemented perfectly. Hybrid ANC combines both feed-forward and feedback microphones. This dual microphone approach offers the best of both worlds, providing a wider range of noise cancellation and greater adaptability to different environments and headphone fit. Most premium ANC headphones today utilize a hybrid system for superior performance, constantly sampling both external and internal sound to create a more effective and nuanced quiet zone. This adds to the complexity and cost, but significantly improves the user experience. Another subtle challenge with ANC is the pressure sensation. Some users report a slight feeling of pressure or even dizziness when first using ANC headphones. This isn't imaginary, it's a real physiological response. When low-frequency sounds are canceled out, it changes the way your eardrum experiences pressure fluctuations. Your brain, accustomed to constant low-frequency background noise, registers this unusual absence as a change in pressure, even if the actual atmospheric pressure hasn't changed. Manufacturers are constantly working to mitigate this effect through smarter algorithms and acoustic design. The constant processing and sound generation required for ANC also come with a power cost. Active noise cancellation significantly drains battery life compared to using headphones without ANC. This is a crucial trade-off. More powerful ANC often means shorter listening times. Engineers constantly balance processor efficiency, battery capacity, and cancellation performance to deliver a compelling product. It's also important to note that the effectiveness of ANC can vary between models and manufacturers, even with similar technology, due to differences in algorithm sophistication and acoustic design. So, what does this all mean for you? When choosing noise-canceling headphones, understand that they are most effective at making continuous, low-frequency background noise disappear, creating a sense of calm and focus. Don't expect perfect silence against sudden loud noises or clear human speech. Test different models if possible, paying attention not just to the level of quiet, but also to the comfort and any pressure sensation you might experience. Remember, the true magic of ANC is in its clever dance with physics, creating a highly effective illusion of quiet, not a perfect void of sound. Just remember, everything here is for education, not personal financial advice or product endorsements. Your situation is your own, so do your own homework before you act. If you found this explanation fascinating, be sure to hit the like button and subscribe for more deep dives into how everyday technology works. Stay curious. This is AI Unpacked.